Hello, welcome to my YouTube channel. I am Somende. Today we will be discussing the basics of welding, the different welding processes, their advantages, disadvantages, and we will only discuss popularly used welding processes only. Welding is a very vast subject. We will not go in detail here. We want to know the know-how of construction process of pipeline. So, let us start. Welding. Welding is a means of joining two material. It can be metallic, non-metallic, but our subject here is fusion welding. So, fusion welding between two metal. Also, like welding, we have another process like brazing, like soldering, where the filler matter only melts. But in the fusion welding, both the parent material and the electrode or filler metal is being melted with the heat of the earth, and a mix up of parent metal and fusion takes place. So the welding strength is very high, sometimes more than parent metal. Okay, now you can see in the presentation there is a very basic definition of welding. It is joining of material with or without use of filler metal, and also with or without application of pressure. Bringing two perfectly smooth and clean material and with intimate contact, which is in atomic distance between the two, is known as welding. So now you can see some basic terminologies of welding, name of the different parts of a weld. In the left hand side you can see the groove weld, and the right hand side you can see a fillet weld. Groove weld single V joint. The bottom is root and the top is the face. At the root there is a root opening, there is a root face. In some British or European terminologies, sometimes it is called as reinforcement, sometimes it is termed as excess weld metal. And in case of fillet, there is a throat and there is a face of a weld, toe of a weld, also it is there in the groove weld. In this slide I have shown some of the types of common joints like single V-bar joint, fillet joint, spot welded joint, plug welded joint and edge joint. This is actually types of weld. So in the next slide we will see, you can see now the types of common welded joint, the joint configuration. When the both edges are getting joint, which is called butt. Butt means at the edge. It can be square if there is no V. If there is a V or groove, then it will be a groove joint. Okay, fillet joint, you can see it is a T type of fillet joint. Then there is a lap joint overlapping, and open corner and closed corner. Open corner is much stronger, whereas closed corner the joint strength will be weak because the weld deposition will be much lesser. But in case of open corner joint, there will be a chance of distortion in the weld. Types of fillet weld: miter fillet, convex fillet and concave fillet. The miter fillet, it is a theoretical fillet. It will be in the drawing, it will be in the design. In practical field, it is not possible to make a miter fillet. If we are welding with a manual arc welding or TIG welding, welding will be convex type. That means in the center, the weld deposition will be more, and at the toe it will be less. If you use machine welding like SAW or automatic F-cow welding, the center deposition will be less and the toe, the leg length will be more. So it is called concave. Now you can see the fillet welding terminology. You can see here, so you can see the fillet weld, these are the fillet weld positions. When it is flat position is also possible for a groove weld, as well as the flat position is also possible for the fillet weld. Similarly, you can see horizontal position termed as 2F if it is a fillet, F for fillet, and when it is position is horizontal in case of groove weld, it is 2G. That means G means groove and F means fillet. Similarly, vertical position is 3F, 3G. Then you can see the overhead position 4F and 4G. There is a comparison, you can see all the positions here in different configurations of joint. For example, in the flat position, in the butt joint, corner joint, T joint, lap joint, edge joint. Whenever welding coming on downhand, then this will be termed as flat. Now Horizontal also possible during the groove weld, during the corner joint, during the T, for the lap and for the edge. So all the joint configurations can be welded in flat, horizontal, vertical or overhead as per the site requirement. Last two slides we have discussed fillet and groove welds in the slides. Now you can see the positions on the pipe. Other than flat, horizontal, vertical and overhead, 1G, 2G, 3G and 4G, there are two more special positions on pipe, which is 5G and 6G. 5G are generally kept in horizontal, not only 0 means plus minus 15 degree from the horizontally fixed pipe. So this is the position actually most extensively used for the pipeline welding. 6G is 45 degree angle plus minus 5 degree. But in the field of welders, we always hear a term 6G welder. What is 6G welder? Why it is not 5G welder? Because 5G position qualify the welder to weld 1G, 3G, 4G, only 3 positions. There is no 2G or horizontal position coming when the pipe is in horizontally 0 degree plus minus 15 degree. So when the pipe kept in 45 degree, then all this 1G, 2G, 3G and 4G position is getting covered. That's why a welder who passed his welder qualification test by keeping the pipe in 45 degree, that means in 6G position, he can weld all the positions. But in the 5G position qualified welder, he is not qualified to weld 2G as well as 6G position of a pipe. So better to qualify welders always in 6G position to have the flexibility on his positions. There is another term 5GR and 6GR. R means rotated. This position is generally used to facilitate welder to weld always in flat position. The pipe is being rotated so that the welder can weld down his hand, which is flat position. Now this slide is a comparison between the international standards. Generally we are using AWS standards extensively in Gulf. The EN European National Standard also describe the positions but in a complete different way and different name. PA, PB, PC, PD, PF and PG. You can see the comparison. Figure here is self-explanatory. AWS is the most extensively used terminologies in our field. We will be now discussing about the welding processes. I told you at the beginning of the slides, there are many types of welding procedures, specialized, automated, but here we will be basically discussing about the manual metal arc welding, oxyacetylene welding and the TIG and MIG welding, which are extensively used for our pipeline construction in oil and gas field. First, let us start with Oxy Gas Welding. Oxy Gas Welding is a fusion welding process which uses a fuel gas and oxygen to provide a flame hot enough to melt the materials to be joined. Here, the oxygen and acetylene from two different cylinders are mixing in the torch and the proportion of oxygen and acetylene is maintained as we require the output. Based on the proportion of oxygen and acetylene, there are 3 types of flames used for this welding process, which I will be discussing in the next slide. So here, this process, you can see the flame temperature goes up to 3300 degrees centigrade, and to bring a very small area of parent metal tip to the melting point, separate filler wire is then dipped into the molten pool. The filler is melted off and mixes with the base metal to produce the weld. Advantages: can weld most of the material, including carbon steel, cast iron, bronze, copper, aluminum and more. But the metal thickness is less than 5 mm because of the limitation of the flame temperature, slow speed of travel and high heat input. Disadvantage of this process. There are 3 distinct flames used in this method. In the neutral flame, where the oxygen and acetylene are equal quantities, it is suitable for carbon steel, cast iron and all low alloy steel and aluminum welding. The carburizing flame or carbonizing flame, which is slight excess of acetylene, this carburizing or carbonizing flame is getting used for high carbon steel for hard surfacing to harden the outer surface of the job. The oxidizing flame, where the oxygen is excess, of course it cannot be used for carbon steel because the oxygen with carbon steel makes a reaction and makes the carbon steel brittle. So the effect of oxygen is severely affecting the mechanical strength of carbon steel material. So this flame is suitable for brass, bronze and zinc applications. For bronze and brazing it is being used. A setup of a typical oxyacetylene gas welding has been provided at the top right corner. This is very simple. That's why it is very extensively used for repairing the car, automobile industries, Now we will go for the extensively used welding process, which is manual or shielded metal arc welding, MMAW or SMAW. Here there is always a power source which can be AC or DC. There are two terminals, positive and negative in case of DC power source and phase and neutral in case of AC power source. One of these terminal goes to the electrode holder where we have to put the electrode at the tip, and another terminal is going to the workpiece or the piece to be welded. The welder, when he touches the job, electric circuit continues to flow and immediately the welder retracts the holder with a very minimum distance. Then the electrode started jumping from the electrode to the metal and it creates the arc. Welder needs to maintain that small gap all through the welding, and with the heat of this arc, the metal as well as the electrode metal both melts and fuse together to create the weld bead. The arc temperature here can reach higher than 9000 degree Fahrenheit. SMAW is widely used for mining, pipeline construction, shipbuilding and marine, machinery manufacturing, steel structural fabrication, nuclear, aerospace, locomotive and defense industry. It is extensively used and excellent welding procedure. Here you can see some advantages and disadvantages of SMAW and MMAW. The advantage, the machine is very simple, low cost, portable, all types of positional welding is possible, outdoor and indoor wherever you can use, less sensitive to weather. If it is outside welding or little bit sandstorm, the TIG welding or any gas type of welding we need to stop because the gas shielding will be blown away by the wind. But we can easily continue the SMAW or stick welding in this weather because here the molten oil pool is not protected by the gas, it is protected by the molten flux, which is a flux cover for the filler metal. Wide variety of power supply, AC, DC, diesel or petrol driven generator, whatever generating current you can use as a power supply. So these are all flexibilities of this stick welding. That's why it is very popular. Disadvantage, you can say low productivity because this is manual, difficult to clean the weld, more heat input and sparks, so safety hazard. Welding halts if you are manually welding a heavy thickness or critical shape workpiece. We need to stop welding time to time to avoid the weld distortion. Manual metal arc welding, MMAW and SMAW. Since it is extensively used welding procedure, there are many researches happened, and from that research we have seen that arc length too low, too short, voltage, ampere, too high or too low, polarity negative or positive, travel speed fast or slow, effects of this. You can see some photograph at the right hand side showing some effect. All of these photos have been taken from Google to use it as my education aid. Friends, you can go through this slide to see the effects of welding parameters, polarities on SMAW or stick welding. This is another extensively used procedure where the production rate is very high because this is a semi-automatic welding procedure, which is called metal arc or manual inert gas welding. If the gas used is active, let's say carbon dioxide, so that will be termed as MAG. And if the gas used are inert, chemically inert, let's say argon welding, that will be termed as MIG welding. In case of MIG welding, it is an improvement over stick welding because an uncoated wire electrode is fed from a roll through the torch and an inert gas such as argon, helium or carbon dioxide flows out around the wire to protect the weld puddle from oxygen. The power supply is connected to the torch and the work, and the arc produces the intense heat needed to melt the work and the electrode. Low voltage, high current DC is typically used to GMAW welding. This method is welding can be used for large volume manufacturing and production work. It is not well suited to repair work because weld quality cannot be easily determined without destructive testing. You can see the MIG welding setup at the right bottom. Process overview for the TIG. We discussed about the MIG in the last slide. TIG is also a gas welding, but this is manual if compared to MIG, which was semi-automatic, because the filler wire feeds automatically from a spool of filler wire. The major difference between TIG and MIG is TIG is using a non-consumable tungsten electrode. The melting point of tungsten is much higher than the welding arc temperature, creates the arc. Argon gas is flowing through the argon torch tip to protect the weld from oxidation, and then filler wire is being fed from the other hand manually if used. That means there is TIG welding which is autogenous. Autogenous means without using filler metal. But for your information, in Gulf for Aramco, autogenous welding is not acceptable. Always we need to use filler metal or electrode. Here the temperature of the arc goes up to 5400 degree Fahrenheit. The electrode is not consumed and uses as a filler, so a filler rod is manually fed into the molten puddle in almost the same manner as when using an oxyacetylene torch. This process needs a lot of welder skill, but the weld production and the finishing is excellent, and it generally used for the low thickness material. Production rate, of course, it is not much higher, but the weld accuracy is very good. The welder can also perform different actions like decorating the metal. For example, when manufacturing objects that require stylish appearances for the purposes of aesthetics, TIG gets the job done. Precise and pretty welds, TIG gives more control and precision. What is the difference between MIG and TIG? We discussed a bit. The MIG welding involves continuously feeding cord through a metal wire into the weld when you are creating. The cord uses the metal to supply easily combine two metallic objects as welder filler material. That means the roll of wire, here mentioned as cord. On the other hand, TIG uses the inert tungsten non-consumable electrode to join two metal objects together and may or may not use filler metal as welding continues. MIG uses consumable filler to combine metal objects. This property makes welding easy when working on larger and thicker material. TIG welding does not always use filler material due to heat being generated. You are only required to heat the TIG torch to be extremely hot for you to swiftly weld thinner material. Now in the conclusion, today we have discussed weld configurations, designs of weld, weld positions, nomenclature of weld, as well as at the end we have discussed the very basics of three major extensively used welding process, SMAW, MIG and TIG. Also we have touched the oxyacetylene gas welding also. Hope you learned something from it. If yes, please don't forget to share like and comment in my video. If you have any questions, you can put in the comments. I will be happy to reply this. Thank you all.